Hi everyone, I'm going to introduce Fase3D, an efficient, encoder-free, Fourier-based 3D large multimodal model. It's joint work between FPK, GQ Lins, and Cero. Today, I will walk you through one core question. Can a 3D LLM understand the full scene without a heavy 3D encoder? I will start with the problem, then our insight, which is to do tokenization in frequency domain. I will walk through the method, show results across 4 3D benchmarks, and close with the takeaways. Today's 3D large multimodal models, such as 3D LLM, LL3DA, 3D Lava, etc., all share the same recipe. They take a point cloud, push it through a dedicated heavy 3D encoder, typically a sparse 3D unit or point transformer, and only then hand the tokens to the language model. That encoder is doing useful work, but it's expensive. We are talking about 100 million plus visual parameters and 40 to 160 G-flops just to tokenize a single thing. That cost limits input resolution, scalability, and the inference speed, and it leaves the open question. Can we build a 3D LLM that operates directly on raw point clouds with no heavy encoder at all? The key idea is, instead of an encoder, we tokenize the frequency domain. Think of FFT as a shortcut. Instead of every token shaking hands with other token, which is what attention does, we Fourier transformer once mix the frequency domain, transformer back. Every token sees the whole thing. So replace the encoder with a tiny MLP. We add an FFT block to the mix context, and we sneak the same FFT trick inside the LLM through a LoRa adapter. That's the whole story. The numbers on the right tells you it works. 10 million parameters and 2 G-flops, roughly an order of magnitude later than the baselines. There are 4 lightweight blocks. The first one, a tiny MLP turns points into features, and the superpoint pooling shortens the sequence by 10 times. The second, the FFT context block makes those tokens globally. The third, a graph-based merger compresses them further. And last one, the frozen LLM consumes them, with our Fourier augmented LoRa on the top. No giant encoder needed. There are 3 innovations make this work. First, FFT context enhancer. Point clouds are 3D and unordered, so we trace space filling curves through the scene. Imagine threading a single needle through every superpoint, 4 different ways. Then graph-based merging. Instead of a learned mask detector, which is what Perla and 3D Lava need, we just vote. Points that are neighbors on the curves vote for an edge. Pure geometry, no learning required. Third, Fourier LoRa. Every LLM block gets a tiny Fourier filter, only a few learnable parameters per head. Basically free, but LLM now sees frequency context, not just local context. Across both ScanQA and ScanRefer, Fase3D produces more fine-grained descriptions than the baselines. It identifies small objects, captures correct attributes such as color and material, and resolves spatial relations more accurately. Here's the results on the ScanRefer dataset. To conclude, we have presented Fase3D, the first encoder-free 3D scene LMM. It demonstrates that frequency domain mixing, space filling curve serialization combined with FFT is an effective inductive bias for unordered 3D data. And the Fourier augmented LoRa can inject global context into a frozen LLM at a negligible cost. Future directions include large-scale 3D pre-training, learned serialization, and multimodal extension to RGB and video. Thank you for listening. We look forward to seeing you in Denver.